Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
What is it saying, by the way? Can you quickly read it out?
In the equation above, A is a positive constant, and the graph of the equation
This
in the
is
xy plane.
this is question number 30. In the equation
Yeah.
above, okay. In the equation above,
Yeah.
yeah.
A is a
A is a-
positive constant, and the graph of the equation in the xy plane is a parabola, which on the phone is an equivalent form of the equation.
all right.
And I said it would probably be B.
Okay, that's y equal to x squared minus a, right?
Yeah.
All right. Okay. Y squared minus a. Interesting. You chose B.
Yes.
Interesting. Why did you choose B?
Because for it to be a single thing, if you times two squares, it just becomes a regular number.
I like that. Well, the correct option is B. But do you remember difference of two squares?
Yeah, I know that. Then it's basically times squared plus the squared number. Then it will be brackets, brackets,
All
and then it
right.
will be the
Interesting. Just so that we don't overlook all that, because there are certain aspect of it that go to page 6. I just want to re-echo what you said. Go to page 5 rather.
Okay.
Let me re-echo what you said with this brief illustration. Just additional information on this. Page 6, please. On difference of two squares. You know, like you said, if you have a squared minus b squared, it becomes what? Just open a bracket and open another bracket.
This.
Mm-hmm. Yeah, what do you write?
Yeah. And then there'll not be A plus B and A minus B,
A
right?
plus b and a minus b. Interesting. All right, so if that is the case, what about if you have this x squared minus 4? What will it give you?
It'll be bracket x plus 2 bracket x plus 2.
Yeah,
X plus 2 bracket x minus 2.
because this 4 is the same thing as 2 squared, isn't it?
Yeah.
So
2
that's
squared, yeah.
that's why it is x plus 2. You can start with plus or start with minus. You see the
Yeah.
same thing.
Okay, x
Now,
minus
what about if you have this? Just if you have 3x squared minus can I say 2x squared minus 50? What will it be?
It would be bracket, no way. Wouldn't be 2, wait, okay. Wait, let me get a pen. See, let me get-
Yeah, to get a pen. I hope it's not far.
No, it's right here.
All right, so go ahead.
So wait, 2.
I thought you should write on your Jamboard on the tablet. Okay, if it's going to be tiny, just go ahead and you can still write on the tablet, and then it's not.
Okay, I can write on the Jamboard then.
Go ahead. And write on
Okay.
it.
I'm trying to say, oops.
But you need to zoom in very well. But if it's not convenient, you can
Okay.
go ahead and write on your paper.
Square.
That's fine.
So if it's 50, then because the square root of 50 is 5 root 2. So if
I like that.
I don't,
I'm
I'm
happy
trying
to
to
give you
think.
this. Yes, the square root of 50 is 5 root 2. That's correct. You are
Oh,
right.
okay.
But then what about this 2? Because this 2,
Yeah,
2 does not have a square root, I hope you know.
yeah. So you'd have to be like, hmm. Would the two go on the outside?
Better. First, so the first thing to do is factorize out the 2.
Yeah.
And because
Okay.
if you're going to put the 2 outside, it has to factorize out every other thing. In other words,
Yeah.
this is what you're trying to do. Um, you are opening a bracket, so go ahead and do that first before you complete it.
Okay. So then would it be sorry? But the thing about it is that if it's x squared, then it won't. Yeah. So how would that be? Because even if I do this, it won't be equal to. It won't be
That's
equal
x
to
squared. You've
2x.
forgotten this is x squared. What you just brought out is
Yeah.
the 2. You've not. So,
That's not. Oh, so you can actually keep the x squared in the bracket.
oh, why not? It's just 2 times x squared, so 2 can stay
Oh.
outside the bracket.
Oh. Okay. I see. That makes sense.
Hmm.
Yeah, that makes sense. I understand now.
Yeah, go ahead and finish it up then.
Okay. So then, if it's now 2x squared is it minus 25, you now, isn't the square root, so now do, and then how do you do it? Because did you put 2 in front of both?
Yeah, 2 is no. It's not 2 in front
Oh,
of both. Let me
oh,
tell you why it can't be. It shouldn't be 2 in front of both. Just 2, and then the other one, because 2 is also a factor.
oh, okay.
Because
So,
if you have, okay, no, don't
so,
clean it. Don't clean it. It's part of the solution.
oh, okay.
Just
I
undo.
just want to put it here on top.
Oh, okay, so write it
That's
there.
what I do.
Okay, write it there,
Yeah.
proper place if you want to write it. Go ahead and write it there.
Okay.
Can you miss that step? That step is important. That first step.
Okay.
That first step. Can
Oh,
you
okay.
clean it and write that first step?
Okay.
Yeah.
Okay, so the first step we now did was first 2, and then we now put
Yeah. I decided to give you this because this kind of questions can. Okay, let's see this other one. Let's see this other one. Nine x squared minus 1. Did you see it?
yes, sir.
9x squared minus 1.
Hmm. Okay. Let me think. 1x squared minus 1. Uh, hmm.
See, that's why I don't just jump into anything. I have it's not just moving on to the next. I want to be sure that a particular concept is properly understood
Okay.
because the questions
Hmm.
can come in different ways.
Because, okay, so if it's 1, then, hmm.
You are thinking very well, and just you'll come up with
Okay.
something.
Would it be, uh, hmm.
I hope you know that 1 itself means 1 squared.
One squared, yeah.
So what's the big deal? And 9 itself means 3 squared.
Yeah.
So
So
yeah,
is it just
wouldn't it just be 3? No, okay, you don't need a bracket.
okay.
Okay, first of all, okay, I think let me even know what you were trying to write, because there could be a bracket. Go ahead, start that bracket. Let me not confuse you.
Okay. I was thinking that if it's uh, I don't know. I was just trying to think. Okay, if it's then that'd be like I was thinking maybe like plus one. I don't know.
Yeah, that's what it will be. It will be something minus 1 and something plus 1. So because 1 itself is 1 squared, you know.
Yeah.
So what plus 1 and what minus 1 do you think it should be?
Um. Will it be 3x and 3x?
You're right. You're right. You're actually very right. Yeah. And why is it that way? Let me just work it out. So that, hold on, let me just work it out. Following the steps, because this will be 3x all squared. That is what this one is. Is that not what it is?
Yes, sir.
Because 3 squared is 9. X squared obviously is x squared. So open a bracket, 3x, then close the bracket, all squared is the same thing as 9x squared. Or 9x squared is the same thing as that. So minus 1 squared. And that's what you simplify it as. You open a bracket, you open another bracket. Am I right?
Yes, sir.
So the 3x either plus 1 and the 3x minus 1. So this kind of thing should confuse you. And then the one we did was that brought up all this was question what again, that says a squared ab.
Yes, sir.
Question 30. I just wanted to add it there, so that when you're reading it, x squared minus a, x squared minus a. So I'll just add it there, x squared minus a, you know. So x squared minus a, x squared minus a is the same thing as writing x squared minus square root of a squared. Do you know?
Yes, sir.
That's what it means, because a itself is square root of a all squared, and that's why it simplifies to what? Open a bracket, open a bracket, x plus a, that's x plus square root of a, and x minus square root of a. I think that's clear.
Yes, sir.
Alright, I think this is basically the form you will get this. Is there any other way? Okay, I think, alright, if we encounter something like this, we can deal with it. Let's go to the next question. That's about difference of two squares. Alright, sometimes in those era of non-calculator questions, there's a way they can ask this and ask you to simplify something. It's like something was shifted. Something was
question?
No, I just realized that something was moved. It's okay, we will deal with it. Something was moved. Something was moved. It scattered this thing, but don't worry. Don't worry. Let me I will deal with it. I will deal with it. Okay,
I think on question 31.
Question 31 now.
Yeah.
Oh, yes, question 31. Question 31.
Okay. Horsepower and wheels Horsepower and
Okay,
watts
that's
are
on
units
page
of
4. Question
yes.
31 is on page 4. Okay. Alright, let's read it out.
Horsepower and watts are units of measure of power. They are
Yes.
directly proportional, such that 5 horsepower is equal to 3730 watts. How much power in watts is equal to 2 horsepower? Okay, I think I know how to do this one.
Alright,
So
go ahead.
if um,
Okay, well, that's just simple proportion.
yeah.
Alright, so 5 horsepower is equal to 3730 watts. So 2 horsepower is
Yeah.
X, you just cross multiply. Okay,
So it is 1492.
1492. Alright.
I
Go
think
ahead, don't go ahead, right? I will just 1492 watt.
1492.
Watt, okay. This is the section where you don't have options. You fill in the answer. They will
Yes, sir.
provide grids for you to type and all that. For the paper type you shared. Alright, so 32.
The painting The Starry Night by Vincent van
Close,
Gogh
close.
is rectangular in shape, with height 29 inches and width 36.25 inches. If a reproduction was made where each dimension is one third of the corresponding dimension, what is the height of the reproduction in inches?
Okay.
If a reproduction was made where each dimension is one third, so do you do one third of the height, original height?
Alright. The painting is 29 inches wide, high and 36.25 inches wide. Now, if a reproduction was made where each dimension is one third the corresponding original dimension, what is the height of the reproduction? And it's just simple arithmetics.
Yeah. Is it not 1/3 times 29?
Yeah.
So 29/3. Because I heard that for the SATs they say that leave things in fraction rather than use decimal, something
Yes.
like that.
Yes. 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 But the previous both methods are acceptable. Like the previous paper type, if you write the answer as 29/3, or if you change it to decimal, which will be what?
9.66 recurrent.
9.66. You can write 9.66 or 9.67. It will all be marked. Do you understand?
Okay. Yes, sir.
Recurring. So I think it's just fine to leave the answer in fraction. Excuse me. Okay.
That's you.
Bless you too.
On PS above, PQ is equal to RS. What is the length of PS?
The number you're reading, question 33.
Yes.
Okay.
Okay. PQ is equal to RS. Okay,
PQ is equal to RS.
Well, PQ is equal to RS. So x minus 1 is equal to 3x minus 7.
All right. Beautiful.
So what we're looking for is are we looking for Q to R?
They're asking us to find P to S.
Yes, what I mean is, because it has X. So are they saying Q to R is equal to X? Or are they saying
Yes,
that
now Q to R is equal to X as given. Yes.
Okay. So P to S is equal to x minus 1 plus x plus
How
3x
about
minus
why
7.
not just find x? You haven't found x yet.
Oh, okay.
Find x first of all, so that you don't complicate this.
Okay. So, um,
So you're solving the equation.
yes, sir.
Minus 2x. Okay. Alright, so minus 2x is equal to minus 6, which gives x equal to what?
So x is equal to wait, so will the x now be equal to
Yeah, x is equal to
3?
x equal to 3. Yeah.
Okay.
So if x is equal to 3, what is p to s?
So then, do we just substitute the values?
Exactly.
Okay. So, okay.
So p to q becomes 3 minus 1, isn't it?
Yes, sir.
Which is 2. Q to r becomes is just 3. This one is also 2. So the length is
Yeah,
what?
so 2 plus 3 plus 2. That's 7.
7 units. Alright, I think that's clear.
Yes, sir.
Okay. 34.
A landscaper is designing a rectangular
This is
garden.
34. Am I right?
Yes, sir. Oh, sorry. 34, not 35. Sorry.
Okay.
In the xy plane, the point 2, 5 lies on the graph of the function. If fx is equal to k minus x squared, where k is a constant, what is the value of k?
Yeah.
So if k is equal to if x is equal to k minus k squared, and x is equal to wait, you know the x that's fx, isn't it would be 2? So would you do like
F of x.
f would you do that?
Yeah. Because x is 2. Based on 2, 5. X is 2, y is 5.
Okay. So
Yeah. K minus 4. When x is 2, what is y?
5.
That's the f of 2. So that's all equal to 5. All these things you wrote is equal to 5.
Oh, I see. So 5 is equal to k minus 4.
Beautiful. Because f of 2 is y.
So k is equal to 9.
Yeah, because f of x is y.
Oh, I see. So, oh, now I understand. So when something says f of something, it just means that f of, let's say, if the coordinate is 3, 6, f
Yeah,
of 3 will be equal to 6.
exactly.
Oh, I never knew that.
Yeah.
Oh, now, okay,
So
let me just,
so f of
I just want to write that down.
yeah, for instance, f of 2 is 5.
Oh, okay.
F of 2 is equal to 5. F of x is equal to y.
Yes, sir.
So exactly K is 9.
Yes. So number 35.
35.
A landscaper is designing a rectangular garden.
Let me see it first
The
of all. Where's 35?
on the other side.
Okay, sorry. Alright, go ahead.
Says a landscaper is designing a rectangular garden. The length of the garden is to be 5 feet longer than the width. If the area of the garden will be 104 square feet, what will be the length in feet of the garden?
Beautiful.
Rectangular.
So the landscaper is designing a rectangular garden. The length of the garden is to be 5 feet longer than the width. Yeah.
So L is equal to with W plus 5.
Exactly. So why didn't you call this one L instead, so that it will make sense?
Yeah.
Why this other one is W?
So
Good.
L is equal to W plus 5.
Yeah.
Okay. So and length times width is equal to so
Yeah. Rectangle area is length times breadth. So W times length is 104. Or W times W plus 5 is equal to 104. Okay, go ahead.
okay. Okay.
Open the bracket now. What you wrote is a simple mathematical expression like W, open a bracket, W plus 5 equals 104.
Yeah.
That's what it means.
So
Good.
and if okay. Hmm. Save
I hope you know what to
104.
do. That's a quadratic equation. Anytime you have something like this, you just change it to a quadratic equation.
Okay.
That just
Okay.
becomes, you know what I mean?
Yeah.
W squared
Okay.
plus 5W
So
minus 104
okay. Okay. Now I can. Okay.
equals
I know.
0. Yeah.
Okay, so minus W is equal to minus 1. So okay. Well, I got for the first. I got
Using your calculator, right?
yeah. So the first one I got W minus 8 and W plus 13.
So it's factorizable equals 0.
Yeah.
Alright, go ahead.
Okay. So now that you have it, the factors.
Okay. What do you have?
Okay, I'm a bit stumped. What do you do after
Okay, quadratic equation. This is factorizable, so it's easy. I thought you had a calculator. You could have just used your calculator to solve all that. Anyways, when you have this and this equal to 0, what it means is either one is equal to 0 or the other is equal to 0.
Oh, I see.
You know, the logic is, just so that you remember, the logic is if you have 8 times b equal to 0, the only way that can be valid is when one of them is 0. Because there's no two numbers you multiply by each other and it will give you 0 if one of them or both of them are not zeros.
Oh, I think, yeah, I did that. I think I just did it in my calculator.
That's what I'm saying. I expected that you would have done solved the quadratic equation with your calculator straight away.
Oh, yeah, sorry. X is equal to, W is equal to 8.
Or minus 13, isn't it?
Yeah.
Alright, so what I'm saying is for 8 times b to be equal to 0, the only two reason is either a is equal to 0 or b is equal to 0.
I see.
Either a is equal to 0 or b equal to 0. Alright, so in this case, because this thing simply means this one in bracket times the other one in bracket equals 0. So either one of them is equal to 0 or the other is either w minus 8 is equal to 0, which will give us w equal to 8 if you solve the equation. You know, minus 8 becomes plus 8 on the other side, isn't it?
Yes, sir.
Just solving the equation. So, or, you know, or w minus plus 13 equal to 0, which gives w is equal to minus 13. So which one do you choose? You have two answers, plus 8 and minus 13.
Plus 8.
Plus 8, because the width cannot be negative, so it's the positive answer you choose. So the width is 8. Now if the width is 8, is it the width we are looking for, the length?
We're looking for the length.
What will be the length? So what is the length?
So the length would just be 13.
It's even 13 directly, because length is w plus 5, width plus 5. So if width is 8, the length is 13. You know, so length is equal to 13. Okay, 8 plus 5, yeah. Alright, so the next one is 36.
Point P is the center of the circle in the figure above. What is the value of X?
Yes. Do you remember circle theorems?
I'm trying to.
Okay.
But I don't really, I'm trying to, because all I see, because I see there's a triangle, but that's about it.
Okay. Can you zoom in? Let me write something. Let me give you some explanation at the top here. Zoom in maybe to 200% because I'm going to draw something really big. Okay. Let me just remind you. Circle geometry. Since you already have an idea, so I will just. Oh, this is too big. I can't be using this. No. Let me start with this. I'm at the left hand side. I hope you know.
Yeah, I just because I'm trying because I'm looking at it on my tablet.
Oh, okay.
Just trying to.
If let me just start with this one that is given. If you have A and you have B, AB is called what?
AB.
What is AB called?
Um, the
I'm talking about what I drew. Can you see what I drew on the left hand side, top left?
yes, I can.
Yeah, what's AB called? Line AB.
I don't know. Is it a circumference or something? I don't
Well,
really
the
know.
whole thing is a circumference. A part of the circumference is called an arc. Arc.
Okay.
Arc. You understand?
Okay.
Arc. That's a part. The entire thing. When you move around a circle, distance around a circle or perimeter of a circle is a circumference. But a part of the circumference is an arc. So you can have a smaller arc, what we call minor arc, or bigger arc, what we call major arc. So you have minor arc and major arc. Alright. So AB is an arc. If an arc subtends an angle at the circumference and also subtends another angle at the center, did you see what I drew? Confirm if you can see what I've drawn.
Yeah, I can see what you've drawn.
Yes, it subtends an angle at the circumference and also another angle at the center. The one at the circumference is half of the one at the center. In other words, the one at the center is double of the one at the circumference. Let me tell you what I mean. If this is x, that's the one at the circumference. The one at the center will be 2x. Did you hear me?
Yes, sir.
By the way, just for emphasis, what do you call this line? This black line? I hope
You call it.
this black line is called a chord.
Okay.
A chord. By the way, a chord is any line that runs from one part of the circumference to another part,
Okay.
not necessarily passing through the center. If it passes through the center, what will you call the line?
The diameter.
That's a diameter. So the diameter is a special kind of chord. Now, why I'm giving you this is you can get a question where you are required to state the name or say something about it, or it is implied in the question. They will just tell you a chord does this, something does this, and all of that. Okay, please, I can't take this for granted. Let me quickly remind you of all this. You need them. You know, I said if you have from A to B, line AB, the line AB itself is the green line A to B is what?
The arc.
Arc. You can call out minor arc if it is a smaller one, or major arc if it is a bigger one. Also from A to B on the other side, which is bigger, is major arc. Okay, because they say you can get a question, the angle for the major arc or the angle for the minor arc, you know. All right, and I said this black line running from A to B is called what?
A chord.
That's a chord. Okay. All right. Why this is an arc? And sorry, let me use the same color. That's color green. This is an arc. Okay, if this is a center O, the center is O, what do you call this line that runs from the center to the circumference?
The radius.
The radius, good. So this is also a radius. If this is a center O. The area bounded by, listen to me, the area whose boundaries, the boundaries are 2 radii, which is the plural of radius, and an arc is called what? The area whose boundaries are 2 radii and an arc. That's this whole region. This whole region I'm shading. The boundaries are 2 radii and an arc, these two red lines and this green arc. This whole area is called what? That are enclosed by those three walls. The walls are two radii and an arc. What is the name of that area? Radius, arc. We call that a sector.
Okay.
Sector.
Okay.
Okay, so let me just say sector, area bounded by two radii. Radii is the plural of radius, and an arc. Did you hear me?
Yes, sir.
You got that. Beautiful. The area, okay, let me show you. This area only, this place, whose boundaries are just a chord and a radius. Okay, before an arc, before I talk about that, do you know that this bigger one is also a sector? This bigger side I'm shading, this bigger side, it's also a sector. This bigger side, why is it a sector? Because the boundaries are a big arc, the big green arc, and the two radii too.
Yes, sir.
It's also a sector. So you have major sector, the bigger one, major sector, and minor sector, the smaller one. Major sector, the bigger one, and minor sector, the smaller one. So area bounded by two radii and an arc is a sector. That's a sector. Okay, I think that's noted. Did you hear me?
Yes, sir.
Now a segment, just like we have sector, we also have segment. The segment is where you have a chord and an arc. A chord and an arc. It's a segment. Segment. You know, area bounded by area bounded, that's whose boundaries, by two things: a chord and an arc. So this region is a segment. Here is a segment because the boundaries are a chord and an arc, the black chord and an arc. So you have minor segment, the smaller one. You have major segment, the bigger one. You know.
Yes, sir.
Beautiful. So you need to understand that. All right. So I gave you the first rule, what we call first circle theorem 1. Look at the first diagram I have on the left hand side. I said if an arc subtends an angle at the circumference, say O, the circumference is at the center. Can I say that again? If an arc AB subtends an angle at the center, the angle subtended at the center is 2x, and then this same arc subtends another angle at the circumference, this angle is x. The relationship between the one at the center and the one at the circumference is such that the one at the center is 2 times the one at the circumference. Does it ring a bell in your head? I think you should remember something like this.
Sort of, yes.
Pardon?
Yeah, sort of.
Sort of, okay. So if the one at the circumference, this yellow x is 45, is 30 for instance. If x is 30, the one at the center must be what? Okay, let me even call here. Let me call here C. Let me call here C. So name, how do we name angle at C? You know how to name angles?
Yeah.
We call it BCA or ACB. You understand?
Yes, sir.
So if ACB, angle ACB is 30, what is angle AOB? AOB will be what? Yeah, AOB will be 60, which is double of it. You know, the one, so the angle subtended at the center is double of the one subtended at the circumference. If it is subtended by the same arc, it has to be by the same arc. What I mean by the same arc is, if you start from A, for instance, and go to the circumference, you have to drop back to B. And if you also start from A, go to the center, you must drop back to B. That is the only time that will be valid. You will understand what I mean by another drawing. Let's move towards the right. Let me add more to this. Alright, so if I have this, I still have my A and B. This is the one at the circumference. This is the one at the center. Now if I have another one like this, if I have another line this way, it's not part of it too. Okay, you understand why. Let me use another color. I think I need to use black now. I want you to notice something. Which colors are subtended by the same arc AB? If you can even say the same arc AB or the same segment, because they are all sitting on the same segment formed here, you know. Okay, so which colors are subtended by, which colors are resting on the same arc AB? Do you understand what I mean?
Yes, sir.
Which colors are all resting on AB? Only the black, the yellow, and the green. The red is not resting on them. The red is the odd one out. I hope you know.
Yes, sir.
Okay. What it means is, the implication is this. So let me zoom this in more and tell you the implication of that. That rule does not apply to the red, because the red is not subtended by the same arc AB. So what I'm saying is, assuming here is X, of course this place will also be X. If the black is X, the yellow must also be X, because they are all subtended by the same arc AB. And of course the one at the center, the green one, must be what?
The green one must be double of the yellow X.
The green one must be double of the yellow or the black, so the green one must be 2x. In other words, the black X is equal to the yellow X, and the green one is double of each one of them. So you can also think of a rule like this: angles subtended by the same arc or the same segment, or if all of them are subtended by that same arc at the circumference, once they are all subtended by the same arc, anywhere they are subtended at the circumference, those angles must be equal. X must be equal to X, But of course, this one will be different. The red one will be different. Why is the red one different? Why is this one? Why will it have a different value?
Because it's not, because it's what, so it wouldn't be equal to.
It is not subtended by this same arc AB, right?
Yeah.
In other words,
I see, yeah.
In other words, it didn't start from A and drop at B. Like the black starts from A, rises to the circumference and drops back at B. The yellow starts from A, rises to the circumference and drops back at B. But the red starts from A, quite alright, but it doesn't drop back at B. It drops back somewhere else. So it doesn't follow that rule. Also, the green one starts from A, gets to the center and drops back at B. So there's a relationship between the green and the yellow, or the green and the black. You know, if I had a blue one, which we just make this thing a bit more mutilated. Okay, sorry, let me just call here. I will just letter this so that you will get this concept once and for all. I'll call this C. Okay. E. It's difficult to write. F. This is F. G. If okay, what can you say about angle AGB? AGB.
It is, it's in the same
yes,
arc,
you're right. It's subtended by the same arc, so it will have the same value too. So it will also be X. AGB will also be X. It will also be X. They will all. So this X here for black is X here for yellow, is X here for red, F for blue. The only one that is different is the Y, because it is not subtended by that same arc or the same segment. You know, they are all, the black, the yellow, the blue are all sitting, as it were, all standing on this segment or standing on this arc. Even if it is turned the other way, you can also think of it like that. You know, they may all be hanging on it or sitting on it. You know. All right, that's the rule. You will get a supporting document to where all of these rules are written down. So I don't want to waste time to be writing the notes. You get a supporting document on. You can also check them on my channel, YouTube channel, Circle Geometry. You know. All right. That's that. Please, this is important, you know, because it's just one aspect that is tested here. Of course, it means many other aspects will be tested. You're expected to know the other ones. If you have this, if this place is the center O, this one is a little bit tricky. What's the angle subtended at the center?
Oh.
What's the value of that angle subtended at this center? What's the value of this angle, obviously?
Do you mean in relation? Oh,
the value 180 degrees. Okay, so if I have this subtended at the circumference, what must be the value of this angle?
Our angle must be wait, 90, right?
Beautiful, 90. It has to be 90. So the angle subtended in a semicircle must be 90 degrees. Take note of this. It's very, very, very important. This is a very common question. The angle subtended by a semicircle, you know, a semicircle is half of a circle, must be 90 degrees, because the one at the center is 180. So here must be 90 degrees. No matter how it is drawn, if you have ABC, angle ACB must be 90 degrees. Must be 90 degrees. So long as AB is the diameter and O is the center. Angle ACB must be 90 degrees. No matter how it is drawn, if I have another one like this, if it drops down here and I call this place E, also angle AEB must be what?
Angle what, sir? AEB
Yeah,
must be 90 as well.
it must be 90 because in a way they are both subtended by arc AB, and of course it is also the one at the center 180 must double the one at the circumference.
Yes, sir.
Stay with me, let's trash this. Look at this. If you have a circle, probably might be familiar with this one. And you have this, what we call cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral. I've reminded you to zoom into at least 200. So anyway, if you're saying it, that's fine, but I have to draw, so I zoomed it very well. A cyclic quadrilateral is a quadrilateral inside a circle. What's a quadrilateral?
It's a four-sided shape.
Yeah, four-sided plane shape, 2D shape. Any four-sided 2D shape is a quadrilateral. For instance, A, B, C, D is a quadrilateral because it has four sides. 1, 2, 3, 4. A quadrilateral is a quadrilateral inside a circle. So, opposite angles of a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral inside a circle. Opposite angles of a cyclic quadrilateral sum up to 180.
Yes, sir.
Sum up to 180. So if this is X and this one is Y and this is A, or let me give another name, P, and this is R, the ones that are opposite to each other must sum up to 180. What plus what must be 180?
Y and X plus Y must be 180.
So
And
X
P plus R must be 180.
X plus Y must be 180. 180, and P plus R must be 180. By the way, we call them supplementary angles. Supplementary angles sum up to 180. Complementary angles sum up to 90.
Yes, sir.
The beautiful word of maths. Okay, 180. X plus Y 180. P plus R 180. X plus Y 180. Okay. Opposite angles of a cyclic quadrilateral, the ones that are opposite to each other, facing each other, as it were. It may not look so, but you have to figure out that it is. For instance, if I have this, can I just draw another one? Because sometimes you may not really, it may not look that much a cyclic quadrilateral, but once it has even this, let me show you. This is a cyclic quadrilateral because the four sides 1, 2, 3, 4 are inside a circle. It's a cyclic quadrilateral. So these opposite sides, this and this, must give you 180 when you add up. I didn't say they will be equal, but they will sum up to 180. Also, the other opposite side, this and this, must sum up to 180. All right. I need you to see this. if you have this, and you have a tangent. You know what a tangent is? A tangent is a line that is closely touching a circle, closely touching an arc or a circle, a curve. The angle between a tangent and any radius must be 90 degrees. This is a radius, this is a tangent. In fact, AB is a tangent, OC is a radius. So the angle between the tangent AB and the radius OC must be 90 degrees. In other words, angle OCB is what?
90 degrees.
Angle OCB is 90 degrees. The other one is also 90 degrees. Angle ACO is also 90 degrees. The angle between a tangent and a radius is 90 degrees. You already know that two radii must be equal, all radii are equal. For a circle, all the radiuses are equal, you know what I mean? Like towards the left hand side, that first line I drew, O to the second line I drew, as you can see, A to B is equal to O to B. So they are. So what we look at triangle AOB. What's the name of triangle AOB?
Triangle AOB.
Yes.
What's the name?
Yeah, there was a special name of triangle AOB. If AO is equal to OB.
OB. Then is it sector?
As I'm talking about the name of the triangle, the name. What's the special name of?
Is it an isosceles?
An isosceles triangle. Two sides are equal. And for an isosceles triangle, the base angles are equal, isn't it?
Yes, sir.
Okay, can I just give you a simple maths here? If you have this, let's talk about this simple maths. Let's talk about this now. If this is 40 degrees, 40, you have to zoom in very well to be able to see it. If this is 40 degrees, what's angle? Alright, you're gonna see something interesting here now. That's 40 degrees. Okay, let me call it a name. Let me call this C. That place is C. If let me just write it here. If angle ACB is 40 degrees, so what's find angle OAB. Find angle OAB. You know what you can do?
What did you say?
See the angle ACB. This angle here is 40 degrees. So what's angle OAB? OAB. That's this angle here. You know how to name angles now?
Yes, sir.
So what's the value of this angle? Don't worry, it may not be so clear. But what's the value of this one at the center? Let's start with it.
Oh, okay. The one at the center is equal 80.
Good. This one at the center here is 80. The one at O is 80. So I can just write it down. We know that. What color can I use now? We know that AOB, angle AOB is 80 degrees. AOB is 80 degrees because the one at the center must be 2 times the one at the circumference. So this is 80 degrees. So if this is 80 degrees, look at this triangle AOB, triangle AOB, triangle AOB, triangle AOB, and you say it's an isosceles triangle. Did you hear me?
I heard you. So yeah, so if AOB is equal to 80 and wait,
And
that's 100.
the remaining one is 100, and two of
Yeah,
them.
so that's 50 each.
So each is 50. So here is 50, this is 50, and this is already 80, so that they will all add up to 180. Interesting. You know, that's just some of the tricks. So AOB is that. Of course, what you did was 180 minus 80 divided by 2. Divided by 2. Because the total angles in a triangle is 180. All of them added together. The one here, the one here, the one here. For triangle AOB, all the angles we add up to 180. So since we know one here is already 80, this one here plus this one here must be the remaining 100. And since they are all equal, being an isosceles triangle, this is 50, this is 50. Alright, that's just some of the things I need you to know. Please stay with me. Let me just say one or two things here, and then we solve that question. I think we have tried by carefully running through this. Look at another one I'm going to. I told you that the angle at OCB is what?
So you cut off
the value. Angle OCB
90
degrees, because one is a tangent, the other one is a radius. Please, you gotta be patient. Let me just tell you something interesting. If you have two tangents, I have a tangent, this one in blue. I have another tangent, the one in red. And these tangents meet at a point. Two tangents are drawn and they meet. Right? The distance from where those tangents are touching the circle, like here, A, and like here, B. Okay, let me write that one in with a blue line. Like this one, A here, and this one, B here. Where they are meeting, let me call it C. The distance from A to C must be equal to the distance from C to B. Did you hear me? If two tangents meet, two tangents drawn from a circle meet, the distance from where they meet to where those tangents, each of those tangents touch the circle, must be equal. They must be equal. You know. In other words, this line must be equal to this line. So what will you call triangle ABC? What will you ABC? What will you call triangle AB? What's the special name for triangle ABC? It's also an isosceles triangle because this line, the blue line, is equal to the red line. You know. So you need to take note of that. You just do some analysis to get all the other things you need. I have to make sure you listen to this thing again because I'm not writing the rules, so at least you will be able to. Okay, I just said that line AB is equal to line AC. AB as a line is equal to sorry, AC, I meant AC, line AC, A to C. Let me make this C yellow. Line AC is equal to line BC. you know. Okay, I hope this one will be helping us to cap this whole thing, and then we look at this. If you have this, I have another I have a tangent this way, and you have something like this. So don't worry, you're going to see it. So that I have, of course, AB is a tangent, and then they are touching the circle at C. You have D, you have E. I want to show you something now interesting. This angle must be equal to this angle. Why this angle must be equal to this angle? Did you see that?
Yes, sir.
All right, so we'll be capping it up here. In other words, we call that alternate segments are equal. That means angle ACD, angle ACD. You know, angle ACD is here. ACD is here, the one in red. Must be equal to angle what?
Must be ACD must be equal to DEC.
Beautiful, DEC. DEC. Also, angle what? Angle ECB or BCE. BCE. BCE must be equal to what? Okay, let me just write it here. BCE.
BCE must be equal to EDC.
Yeah. BCE must be equal to EDC or CDE. You're right. CDE, if you like. You know. So we call that opposite segments, angles in opposite segments are equal. Okay, I think these are basically what you will need to understand. Let me just see. Okay, can I just say this, though this one is not really a common, but it can help. Look at this one. It can be proved, but it's good for me to just tell you. If this is a center, I say you will need to listen to this. If this is a center and an angle is formed here, this angle here and the one here and the one here with sum up to 180. So let me write it down here. This one at O, can you see what I'm drawing? Name it. That's AOB, isn't it?
Yes, sir.
AOB plus what? ACB plus ACB plus ACB must give you 180 degrees. The angle here and the angle here must add up to 180. The one at the center here and the one at where the two tangents meet must sum up to 180. Alright, so I think that's basically what all that is. Okay, please, it's a lot of rules, but you practice and get used to it, you know. No, nothing serious. Did you hear me?
Yes, sir.
Okay, As a matter of fact, I have to quickly, let me see. Okay, let me just draw this. I just noticed that there's one rule I didn't tell you about. If this is a chord and this is from the center, a line is from the center here, you know, any
Yes, sir.
the radius that divides the chord into a radius that divides a chord into two equal parts must form angle 90 degrees on both. Okay, of course this is O, the center. This is the OB is a radius. OA is a chord. OA is also a radius. I hope you know. OC is a radius. Do you know?
OC. Yeah.
Even though
Yeah.
I didn't draw mine to scale, because once you start from the center to the circumference, that's a radius. OA is a radius. OB is a radius. OC is a radius. OA radius. OB radius. OC radius. And they are all equal, because all radii are equal. Lines from center to circumference will all be equal if it's a proper circle. I don't know if you still remember the name we call A to C. What's that name again?
A to C is the chord.
Chord, good. A radius that divides a chord into two equal parts must form angle 90 degrees, with the chord. Once that radius divides the chord into two equal parts, it must form angle 90 degrees with the chord. So here 90, here 90. Or once it forms angle 90 degrees with the chord, it must divide it into two equal parts. Okay, but that's not a big deal. It's something that can easily be figured out. Alright, so very quickly, this question, with what I've said, you can easily take this question. Very quickly, see it? It's so easy. So easy. You see this chord BC?
Yes, sir.
Sorry, this arc. What do we call this? Is it not an arc BC?
Yes, an arc.
But if you like, you could have also called this straight line that I'm going to draw in yellow. That's also a chord. That's also called BC. This straight line is a chord. BC. So this arc subtends this angle at A at the circumference and subtends this angle X at the center. So what do you say about the one at the circumference here and the one at the center?
It's two.
The one
Angle BPC is 2 times of angle BAC.
Okay, so we can just simply call this one X over 2, isn't it?
Yes, sir.
Yeah, this place is X over 2, X divided by 2, while here is X. Okay, having said that, what else do what is the question again? Just read the question. What's the value of what?
What is the value of X?
Okay, we're looking for X. Interesting. What's the value of X? Okay, here is this place, and this place must be equal because they are base angles of an isosceles triangle. P being, in fact, triangle BCP is an isosceles triangle. You know that now. Yeah,
Yes, sir.
these are radiuses, so they are equal. This is equal to this. Line PB is equal to line PC. Line P to B is equal to line P to C. You know that?
Yes, sir.
So this is an isosceles triangle, like we said earlier. So if this is X, what should here be? These two should be 180 minus X divided by 2.
Yeah.
Just like we did in the other one. Do you know what I mean? Because if we add this to this to this, we get 180. So if we remove this one, that's 180 minus X. So each of them will be that 180 minus X divided by 2. So here is 180 minus X divided by 2. This one is also 180 minus X divided by 2. And just use a number to make it come alive. Assuming this was 50. This was what? Let's say, can we just say 40? What number can I give? Assuming it was 80. Just assuming this is 80. Are you listening to me?
Yes.
If this is
Yes, sir.
80, if this is 80, everything in this triangle B, C, P, all of it sums up to 180. You know that?
Yes, sir.
So if this is 80 degrees, the remaining one will be 180 minus 80, which is 100. So each of them will be 50, each of them will be 50. So 180 minus x divided by 2 will be the value of each one. Do you agree with me?
Yes, sir.
All right. So if that is it, we have gotten the answer. And all of them, these 20, see, x plus 2, x over 2, 20, 180 minus x over 2, 180 minus x over 2, then 20 will all sum up to 180. Can I write it down so that we conclude? Just write it down. What I'm saying is this yellow, this 20, this 1, this 1, and this 20 will all sum up to 180 because that is the big triangle. Look at triangle ABC, the big triangle ABC. The big triangle ABC. Do you see that? The big triangle ABC. Let's write it down now. So x over 2 plus 20, that's this 20, plus 180 minus x over 2, oh no, not enough space, plus again 180 minus x over 2, and of course the other 20. Let me start it from here since we didn't have enough space there, so that you just see what I'm doing. We're almost done. What I just added is this, please. You know, look at this whole triangle, this big triangle ABC. Can you see it?
Yes, sir.
This whole big triangle ABC. All the angles you have there is x over 2, 20, 180 minus x over 2, 180 minus x over 2, and 20. So 20 plus 1 x over 2 plus 20 plus 180 minus x over 2 plus 180 minus x over 2 will all give you 180. All of that will be equal to 180, you know. So that's what we just solved to get the answer. You know, sorry, I can see, you know, you're getting tired. All right, this is simply, let's just solve it and conclude. This will be 180 equal to 20 plus 20, that is 40, then plus x over 2, then plus 180 minus x over 2 plus 180 minus x over 2 will just give us 180 minus x, you know. I'm solving the equation. It's something you can easily solve. I'm solving this equation.
Yes, sir.
This minus x over 2 plus this minus x over 2 will just give us 180 minus x without over 2. It's just like saying half plus half. What is half plus half?
1.
One full whole number. So 180 minus x over 2 plus 180 minus x over 2 will give us one whole number, that which is 180 minus x. Okay, so let's just solve this. That will give us, let's take 180, we cancel out 180, 40 will go to the other side. I want to cross out something that this will cancel out this, 40 will go to the other side. So we have simple solution of equations, which I know you can do. Am I overestimating your ability? I know you can solve this equation, can't you?
Yeah.
You should. You should. You know, if you have 180 here, you have 180 here, you have 180 here, just cross it out because we can't waste time on that. Just cross that out. And what we have left is 40, then x over 2, and then minus x. So let's take all the x's to the other side. Minus x crosses the other side becomes plus x. Then this one crosses the other side becomes minus x over 2. You know, any method you know you can use it to solve the equation. That's all I'm trying to do. There's no special thing I'm doing. It's just to solve the equation, you know, and that's equal to 40. x minus x over 2 will give us half x. So x over 2 is equal to 40. That gives x equal to 80. So that's the value of x. All right. Anyway, it's not as difficult as it looks. It's just that I had to prove all of this to help you appreciate it. So, all right. Just listen to it again. Listen to the rules, because as it were, you have to learn the rules again. Listen to the rules again. Listen to the rules again. It will make sense. Okay.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.